Hello and welcome back to our video. In this problem, we're told that we have a rectangle which was altered by increasing its length by 10% and decreasing its width by p%. So the length is going from, let's call it L, which is going to represent the original length, and then we're increasing it by 10%. 10% is equal to 0.1. Therefore, the new length is going to be L plus 0.1 L, which is 1.1 L. Then decreasing its width by p%, it's going to go from W to some new multiple of W. We don't know it yet, but let's just call it X. This is going to correlate to decreasing by p%. So we're told that these alterations are decreasing the area of the rectangle by 12%. So the area, the old area, equals the new area equals the old area minus 12%, 100% minus 12% is 88%, which correlates with 0.88. So 0.88 times the old area equals the new area. So the old area was L times W, since the area of a rectangle is length times width. So we have 0.88, L times W, length times width, is equal to the new W, which is 1.1 L, times XW, where X is just some constant, which is representing a decreasing by p%. So if we divide both sides by LW, these L's cancel, these W's cancel, these L's cancel, these W's cancel. We get 0.88 is equal to 1.1x. Dividing both sides by 1.1, these cancel, and we get x is equal to 0.88 divided by 1.1, which is 0.8. So when you decrease the width of the rectangle by p%, W becomes XW, which is 0.8 W. So W is now 80% of what it was. And this correlates with 100% minus 80% equals a 20% reduction. So the decreasing of its width by p%, we decreased it by 20%, which left us with 80%, which is giving us the multiple 0.8 W. So decreasing by p%, decreasing by 20%, P correlates with 20, so C is going to be your final answer. As always, thank you for liking and subscribing, and I'll see you in the next video.